In this pre-lecture video, I want to start to develop a few more MATLAB skills. In particular, I want to talk about how to define your own functions in MATLAB, which you can then use to do things. And then we will also use some of the built-in functions in MATLAB which need this skill. And those are going to be really useful functions for us that help us to calculate integrals using MATLAB and also to solve equations which you can't solve by hand. So let's get into it. Okay, so the plan here is we want to talk about defining your own functions in MATLAB, and then we want to talk about using some built-in MATLAB functions which use functions that you have defined. And these are the functions fzero and the integral command in MATLAB, and both of these functions will use functions that you have defined. Okay, so first thing is, how can I define my own function in MATLAB? There's two ways to do this in MATLAB. The first one is called inline or anonymous functions. And these are functions that you can define at the beginning of a script. So define within a script. And usually these are just one-line functions. Simple one-line functions. There's another way, if you want to make your function more complicated, you can use a separate file. And that way you can use, you can make your functions more complicated. But because we're just getting started, we're going to focus on this method in this class, the functions that I define within a script, and they're basically just one-line functions. Okay, I'm just mentioning to you that there is another way, which is using a separate file. And you can take a look at the lecture notes if you're interested in that. I gave some examples on how to do that. But what I'm going to focus on here is just this method. So here's how it works. You add the line as follows in MATLAB. So I'm going to put here f equals at symbol and then x and maybe y. And then you could put other arguments here as well. And then what goes here is basically what you want the function to do. So put what the function does here. So let me just go over a little bit about what's going on here. This thing here is the name of the function. And MATLAB has a funny name for this. They call it the function handle, which is easy to remember because or in any online system, you have a handle, which is like your nickname. That's the name of the function handle. This thing here tells you about the arguments of the function. You need this at symbol to define the function. So let me kind of demonstrate that in an actual example using MATLAB. So here we've got the MATLAB window open, and I've started a script which I've just called my first function, and I'll start the script the way I start every script, by starting with clear, close all, and CLC. Okay, now maybe I'm going to define a function which I'm going to call hypotenuse. Maybe I'll just call it HYP. So that'll be the name of the function. And this function is going to do the following thing. I'm going to give it two sides of a right triangle. so like the A and the B, and it's going to tell me what the hypotenuse of the triangle is. So a squared plus b squared is equal to c squared. I want the hypotenuse, which is the c, given if I give it a and b. So it's going to have two arguments. So we're going to put here at, this telling it it's a function, two arguments. Let's call the arguments a and b. Okay, so that means my function, which is called hyp, that's the name of the function, takes two arguments, a and b. Okay, now I have to tell it what the function does. So I want my hypotenuse to be a squared plus b squared equals c squared. So c is going to be the square root of a squared plus b squared. Maybe I'll put a semicolon at the end of it. That's it. So I've defined my function now. So if I run this script, I can see that something has happened. I can see this hyp, hypotenuse function, up here. And to use it, I can call it with anything I want. So for example, in the commandment window, if I call hyp, let's say one side of the triangle is 1 and the other side of the triangle is 1, well, that's a 1, 1, square root 2 triangle, so the answer will be square root of 2, which is 1.14, right? If I call it with some different arguments, I could say hyp of, let's say there's a 3, 4, 5 triangle, right? So 3 squared plus 4 squared is 5 squared, so if I called it with 3 and 4, I should get 5 out, and I do. Okay, so any two sides of any triangle I can put in here, and I will get this function calculates a squared plus b squared, takes the square root, and gives me the answer. So fairly straightforward, right? That's a nice way to define your own function. If I'm going to use this over and over again, I don't want to have to type in there a squared plus b squared square root every time. I can just type this, the name of the function, and then call it with those arguments. In MATLAB, you have to be very careful keeping track of what different different variables are. What kind of objects are they? Is it a matrix? Is it a list? Is it a number? Here's a fourth thing that a variable can be. It can be the name of a function. So this hyp is not a number or a list or a matrix or anything like that. If I type hyp in the command window, what it will tell me is function handle with this value. So that means that's the name of the function. I can't do anything with that, right? Except for I can call it. All right, so I couldn't type like hyp plus 2. That doesn't make any sense because it doesn't know how to do that on the name of a function. Okay, but I can call hyp of 3 and 4, and then I get 5 out of it. So just be clear of, if you see like function handle showing up somewhere with an error message, it means you probably forgot that that was just the name of the function, not anything that you can do any mathematical operations with. Okay. So we know how to define functions now. Very simple example. You just add this line somewhere at the beginning of your script, tell it what the arguments are, give the function a name, and then tell it what the function should do with those arguments. Okay. All right, now I want to go back to the notes here and talk about two special functions in MATLAB that are very useful. And they use these function handles. So I had to explain what a function handle is first. Now I can start talking about these two functions in MATLAB which are very useful, fzero and integral. Let's do integral first because it's kind of the obvious one, or that's the easiest to understand. All right, so the first one we'll do is MATLAB's integral function. And it's very straightforward. If you want to do an integral like this, as an example, let's say you want to do this integral. It does definite integrals for you. So let's say sine squared of x dx. I want to do this in MATLAB. By the way, you know the answer to this. You can do it by hand. So you don't need MATLAB for this. The answer is pi. But what if I have an integral that I can't do by hand? I need to put it in MATLAB to do it. It's very simple. Here's how it works. You first define the function that you want to integrate. So I would say f equals at x sine of x squared like this. Okay, so this is defining the function f, and that's the function I'm going to integrate. And then to actually do the integral, it's very simple. I just type in this function, integral, and the integral function takes 3 arguments. The first one is the name of the function that I want to integrate. So that's that function handle, right? The name of the function to integrate. And then the second 2 arguments, or the second and third arguments, are kind of obvious. The lower limit, and then the upper limit, 2 times pi. So 3 arguments. The first one is the name of the function, lower limit, and then the upper limit of integration. And that will give you the result of the integral, the number. Okay, MATLAB doesn't do, it's not going to tell you the function, it's going to tell you the number for the numerical integral. So let me just illustrate that using a real script. So I'm going to go back to my MATLAB script, and I'll change my function. So maybe I don't want it to be hypotenuse anymore. We're going to do f equals sine of x squared, just like that. Okay. And then I'm going to type in integral f, the name of the function. So I'm not passing any arguments into the function. This integral function takes the name of the other function, integrated from 0 up to 2 pi. And you already know the answer to this should be pi. So let's see what happens when I run this. The answer is 3.14159. Okay, so it came out with pi. So it did it right. So I can put any function in here, you know, maybe like e to the minus x squared, right? We said that was a hard one to integrate. I can put it in, and it will tell me what the number is for that definite integral. Okay, so it only does definite integrals. Name of the function, lower limit, upper limit. Couldn't be simpler. Let's talk about one other useful numerical function, which is called fzero. And what this is used for is to solve algebraic equations. Numerically. Maybe you have an equation that looks like this. Minus x is equal to the natural log of x. Solve for x. Okay, so you're thinking, okay, I know how to do this. I'll take both sides, e to both sides, so then I have e to the minus x on this side is equal to x. But that doesn't help, right? Because now to get this x out of the exponent, I have to take the natural log, and I just end up back where I started. There's no way to solve this for x, actually. So it can't be done by hand. You can only approximate it. And there's a couple ways to actually approximate it. One way that maybe you learned about in high school is to graph both sides. So I could graph natural log of x, and the natural log of x looks kind of like this. And then I could graph the line y equals minus x, and that would look something like this. And I would find where they intersect. I would kind of zoom in on the intersection point, and that would tell me what the value of x is, right? But luckily, there's a better way. I don't have to like zoom in and make graphs. I can just use MATLAB to do it. And that's what this fzero function is for. So fzero is going to find the solution to an equation which you can't solve by hand, or one you can solve by hand if you want to check your work, okay? And here's how it works. So using the fzero function to solve an equation. The first step is you write your equation in the form some function f of x is equal to 0. Okay, so in other words, you make one side of the equation 0. This is an important step, and this is a step that most people forget. Okay, as an example, if I'm trying to solve this equation, minus x is equal to the natural log of x, the one I did above, I should write this in the form something is equal to 0. So I should put the x on the other side, and I would have natural log of x plus x is equal to 0. And so this is the function f of x is equal to 0. Okay. Once I've done that, I define that function in MATLAB. And it looks like this. So it would be f equals at symbol of x, so x is the argument, natural log of x plus x, just like that, without the 0. So it's just the thing that is equal to 0. Okay, log of x plus x. MATLAB uses log for the natural log, so that's why I'm writing it like that. And then I call this function fzero. And it takes two arguments. The first argument is the name of the function that I'm trying to find where it's equal to 0. And then the second argument is just an initial guess. So I'm going to have an initial guess of 0.5. So this is your initial guess. How do you come up with your initial guess? The best way to do it is to make a graph so you can have some idea of where this occurs. Because the problem is this function might be 0 in many places, and you want to make sure you're getting the right one. So you want to give MATLAB some idea of where to start. Okay? And then it will tell you exactly where these two things are equal. Let me illustrate that using the script. To start, what I did is I plotted this graphically the way I described. Okay, you can see by graphing, the black circles are the natural log of x. So you can see I've got a plot command here, x log of x, OK means black circles. And then I've got x minus x, so the rs, that's the red squares. So the red squares are the line y equals minus x. And the black circles are the line y equals the natural log of x. And you can see they cross somewhere close between 0.5 and 1. Okay, so this is an idea. Now, suppose I want to know exactly where this is. I don't know exactly. I mean, I could do it by making a bunch of plots and zooming in, but that's a pain. But at least I have a rough idea that it's somewhere between 0.5 and 1. Okay, now we'll use this to actually use MATLAB to calculate very accurately where these two lines cross. Okay, so let's do that. So let me get rid of this. We know it's somewhere near 0.5, between 0.5 and 1. So let's define our function. So the function I'm trying to find where it's equal to 0 is x plus the log of x. So remember, this function is defined to be, it's trying to find the place where this is equal to 0, where x plus log of x is equal to 0. And then I just call this function fzero. Maybe I should put a semicolon here. The name of the function, without any arguments, just the name, and then where to start. So let's say 0.5. And let's run it. Here's the answer, 0.5671432. Okay, so this is going to be my answer. Let's call it answer. Right? And we can check it. We could say answer is 0.567143229, and what is the natural log of the answer? It's also equal to minus 0.567143229. So I found this value where the natural log of this is equal to minus the thing itself. So that's a way you can solve an equation. If you can't solve the equation by hand, you can use this fzero function. All right, so I hope you found these skills to be useful. We talked a little bit about how to define functions in MATLAB, so with the syntax that you need for that, and we've talked about how to put this into a script. And then we used those function handles, or these function names, in two of MATLAB's other functions. So one is integral. I can do an integral of any function that I define. So I defined a function here, sine squared, and then did this integral. And I can also find the place where any function is equal to 0, and that's great for solving equations which you can't solve by hand. Okay? So we'll pick it up there in class. We can kind of talk about some additional examples and do some polling questions about this. And I think this is also enough to get you started on your homework. Thanks again for listening, and see you all in class.